Okay, so this lecture I just want to talk about is a very simple point. I just want to make the point that when you do regression with orthogonal covariates, then actually it's essentially the same, the likelihood's the same as the normal means problem. So that means that in that special case where you're doing a regression with orthogonal predictors, orthogonal covariates, then we can just use shrinkage methods like empirical Bayes shrinkage methods for the normal means model. We can apply them directly to the regression problem. So that's a nice special case, simple special case. So that's this bullet here. So let's just look at the math here. So all this math is telling you, you can go through the math on your own, but this is the regression, and sorry, there's the regression, and here's the normal means. Oh, sorry. So you can see if you look at a regression here, the x's are going to be assumed orthogonal. If we assume the x's to be orthogonal, then the log likelihood term we get here, which is here, has exactly the same form as the log likelihood for the much simpler, normal means model, which is here. So the derivations are very straightforward. They're just showing that there's a direct correspondence between the log likelihood, or the likelihood for the regression coefficients B in the regression model when the x's are orthogonal, and the theta, the means, in the normal means model. And the correspondence is that the data, the x's in the normal means model, sorry again, the x's here are the b hats in the regression model. So essentially, the intuition, what this is saying is that you can do inference for the regression coefficients in the orthogonal case by first computing the b hats and their standard errors, and then treating them as if they were the normal observations from the normal means model. So in other words, you treat the b hat in the regression as an estimate of b, a noisy, well, it is an estimate of b. It's a noisy observation of b. It's so it's normal with mean b and some standard error that you have. So it's exactly a normal means model. Okay. And doesn't matter whether they're exactly, there's some scaling issues here, but so the idea is that if I have a computer program that will fit the normal means model by, say, empirical Bayes, I can apply that procedure directly to the regression case by simply plugging in the b hats and their standard errors into my normal means problem. Okay, so make sure you go through that carefully so you understand it. You might think that it's too special a case to be interesting where the x's are orthogonal, but we're about to do an example of that. It comes up, for example, in using wavelet shrinkage to do smoothing. So we're going to talk about that in a minute. So that motivates why we might do it that way. Okay, so go through it carefully and then go on to the next lecture.